Instruction skill 24 is about solving for distance using the Pythagorean relationship. And the Pythagorean relationship states that the sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. And you might be thinking, that sounds like Greek. It is Greek. Pythagoras lived in about, I believe, 550 maybe BC. He lived in ancient Greece, and he developed this formula that works for right triangles. Before we get to that, let's take a minute and just talk about or think about, you already know this, let's just put it together here. You know that a right angle looks like this. It makes a perfect corner. Okay, that is a right angle. If you color that angle sign, the things attached to it are called the legs of the triangle. Don't want that so big. So this is a leg, and this is a leg. They're the legs of the right triangle. Then you have this thing that is diagonal between the top of that one and the side of that one. This is called the hypotenuse. Okay. The hypotenuse is always across from the right angle. If you make an arrow out of that right angle, it is pointing to the hypotenuse. The hypotenuse will always be the longest side. So here's basically what Pythagoras was thinking. Let's suppose that, let me take away this. We'll come back to those terms. But let's do our own little story about this. Let's suppose that I live here and that I work over here. Okay. So to get to work, I can drive south, turn this way to get to work. So maybe this distance is 3 miles, and this distance is 4 miles. How many miles did I drive to get to work? I went 3, I turned and went 4 more, so I drove 7 miles. Do you see a better way? This is what Pythagoras said, that the shortest distance between 2 points is a straight line. That if you're going here and turning, you're driving more than you need to. To go from home to work the way a bird would fly, you would follow the hypotenuse. And the hypotenuse is 5 miles. So this is the type of problem we're looking at. The leg plus the leg in this one is 7 miles. If you follow the hypotenuse, you're only driving 5 miles. So you could cut 5 miles off of this trip. And that's the type of problem that Pythagoras was working with. And that's what this formula says. C is always your hypotenuse. B is always one of the legs. And A is one of the legs. And this book is using the word side to represent a leg, so they may use that term. I would use the word leg. That's the more proper term. The legs are attached to this right angle, and hypotenuse is the longest side. It's the diagonal side. And the Pythagorean formula or Pythagorean theorem or Pythagorean relationship is this: that a squared, and remember a is a leg, so one leg squared plus the other leg squared equals the hypotenuse squared. And here's an example: 10, 8, and 6. So 10 is the hypotenuse. The legs are 6 and 8. And let's see if this formula proves true. One leg squared plus the other leg squared equals the hypotenuse squared. 8 eighths are 64. 6 sixes are 36. And 10 tens are 100. So this proves to be true. So let's look at something. Let's take our 3, 4, and 5 and our 6, 10, and 8. I want to show you something. So I'm going to add a piece of paper, if it will allow me to, just like I did for those bow ties that we did. So let me start with just a little right triangle. So I'm going to use my grid lines here to try. Actually, let me do this because I want it to be to scale. So I don't know if you can see those grid lines, but I'm going to use them. So I want to have 4 here, 3 here, and 5 here. So this one we have 5, 3, and 4. Okay, that second one that we did had 8, 6, and 10. So this was 10, this was 6, and this was 8. What does that remind you of? Remember those mama and baby triangles? I cannot, wait, I might be able to. I would need to do a 16, let me just do it this way. So if this is, these are not to scale, by the way. So here's 3, 4, and 5. And I'm going to make a copy of that. And I'm going to enlarge it. And then we're going to change out the numbers. So this one, let's say, is 2 times larger than the first one. So 5 times 2 is 10. 4 times 2 is 8. 3 times 2 is 6. I have no idea where that came from. Let's try this again. Let me make a copy and enlarge it even more. So let's make this one be 3 times bigger than the first one. So here we have a baby, a mama, and a grandmama. So 5 times 3 is 15. 4 times 3 is 12. And 3 times 3 is 9. So this one is 3 times larger than the original. My point here, you cannot just pick 3 numbers at random and make them fit this relationship. These are called Pythagorean triples. And I know I'm on a tangent here, but this is important. So 3, 4, 5, 6, 8, 10, 9, 12, 15. Those are Pythagorean triples. So here's why I went through all this. What if you get this question on the test and you only have 30 seconds left? If you know this trick, you know this answer. So here's the question. Let me think it through. And you say, there's no way I can answer that in 30 seconds. But you can if you know this information. That's a mama and a baby. You've got the baby over here, the mama's up there. So from 3 to 21, that's 3 times 7. Five times 7 is 35. So to find this missing one, you're going to need 4 times 7, and that's 28. So without working this problem out, if you know about Pythagorean triples, you can solve that question without even picking up a calculator or a pencil. It is important to understand that concept. If you have time, you can also set up a proportion and solve it as a mama-baby problem, and it will work just fine. But sometimes you don't even need to work these if you understand about Pythagorean triples. Okay, let's look at this word problem, and this is going to help me right here, knowing about Pythagorean triples. Alfonso knows that the distance across the field from his home to Carla's home. So we are talking about this distance. Let me get a highlighter. This distance is 50 meters. A nice place to pick flowers is 40 meters directly east of his home. So here's Alfonso, and here's the flower spot, and directly south of Carla's home. How far is Carla's home? How far from Carla's home is the flower picking spot? So we're looking for D here. Now I'm going to do this the way I'm supposed to, but I want you to notice something. Remember that little baby? 3, 4, 5. Look at what we have here. We have 50, 40. So what would you guess that missing piece to be? It's 30, because we know the 3, 4, 5 goes together. They've just added a 0 here. So the answer would be 30 meters. I don't even have to work this problem. But if I did work the problem, this is what I would do. First of all, I have to know that this is a right angle, or this formula will not work. But if it is a right angle, Pythagoras' formula will work. And it says a squared plus b squared, those are the legs, equals c squared. So here is c squared. Here are the legs of the triangle. And we just need to do some math. I know one of the legs. I know the 40 squared. I don't know the other leg. But I do know the hypotenuse. That's 50, and I'm going to square it. You can use your calculator. 40 times 40 is 1600. 50 times 50 is 2,500. And we don't know this one yet, but we're about to. So if I take away the 1,600, and algebra says I have to do it to both sides, you really need to know how to do algebra before you do this. But they've chosen to put it here, and that's okay. You take the square root of both sides. So B equals, not 90, B equals 30 meters. Now, I can absolutely use this formula and get that answer, but if I know my Pythagorean triples, I don't even have to work that out. I know that 3, 4, and 5 go together in this relationship. The key to solving this problem is recognizing that it is a right triangle problem, where the lengths of two sides are known. The Pythagorean relationship tells you how to find the length of the missing side. Step 1. You write an equation that represents the relationships of the distances. First, name the unknown distance d, then use the Pythagorean relationship to write an equation for d. We know that d squared plus 40 squared is 50 squared. To solve the equation for d, you must get d standing alone on one side of the equation. First, subtract 40 squared from both sides of the equation. Now take the square root of each side, find the values of the squares, subtract 1,600 from 2,500, finally take the square root of 900. Carla's home is 30 meters from the flower picking spot. If I know that 3, 4, 5 go together, I can avoid all this. And that's why I took us down this road. Because if you know this part, you can sometimes avoid this part. They do show you how to do this on the calculator. I encourage you to work through that and also to look at the computation pages that go with this lesson. Let's practice. Which is the best estimate of the length of side AB? Assume that the diagram may not be drawn to scale. All right, so let's look at this one. I'm not very good at just reasoning these, so I'm going to actually do the formula. I know that this is 90 degrees right here. And since I'm practicing, I'm going to do a little bit more than I have to. If this is 90 degrees and that's 70 degrees, I could tell you that that missing angle is absolutely irrelevant, but it's good practice. 90 and 70 make 160, so that leaves me with 20 degrees for this one. It's great to know, but it doesn't matter a hill of beans here. They want to know this distance. They want to know the length of this leg of the right triangle. So since it is a right triangle, Pythagoras is going to help me solve it. Now, it's not in one of the triples that I've memorized, so I am going to use my formula. And I would set up the formula as a squared plus b squared equals c squared. And I will tell you that this formula looks horrendous and scary until you get used to it. If you will practice it, you will do well with it. All right, so A, I'm going to use that as one of the legs. The other leg is 3 squared. The hypotenuse is 6, and I'm squaring that, so 6 squared. So A squared plus 3 times 3, that's 9, equals 6 times 6 is 36. Then I will take the 9 off both sides. So a squared is going to be 36 minus 9, and that is 27. So I have to take the square root, and I do not have a calculator. So here's how you get around that if you don't have a calculator. The square root of 27 is what we're looking for. That's going to be our A. Go to your nearest two perfect squares. So I know the square root of 25 is 5, and the square root of 36 is 6. And I know that the square root of 27 is between those, and it's going to be closer to 5 than to 6. So I'm looking for something between 5 and 6, and that's going to be number 3. They say between 3 and 6 meters, and you could actually look at this. We know that hypotenuse is always the longest side. This one, just eyeballing it, is the smallest one. So this one has to be somewhere between those. You could absolutely reason it that way. Number 2, Georgia hiked 6 miles north. That's this distance. And 2 miles east from the campsite. So she went for 8 miles. Those are the legs of a right triangle. Which expression can be used to find D, the straight line distance, in miles that Georgia is from the campsite? So we're looking for hypotenuse. All right? So let's set up our formula. You can absolutely use reasoning if that's your thing. A squared plus B squared equals C squared. And we know the legs. So we know that 6 squared and 2 squared will give me hypotenuse squared. So 36 plus 4 is C squared. So I'm looking for the square root of 40. And if we look at our choices, we know that we did what to the legs of this triangle? We added those legs. So I'm looking for something that involves addition. I would get rid of number 2. I would get rid of number 4. And that leaves me with 1, 3, and 5. I can eliminate 1 because it does not have the square root sign, the radical. At some point in this problem, I had to take square root, and number 1 does not do that. So the question is, do I square the 6 and the 2 and then add them? Or do I add them and then square them? And the answer is number 3. We had to add those numbers and then, we had to square those numbers and then add them together. You have to follow the order of operations. No procedure question this time. They jump directly to application, which is fine by me. To frame a picture, Pegasus Framing Gallery has a labor charge of $3.50 per inch of the picture's diagonal. Materials are an additional charge. What would be the labor charge to frame this picture? So we have a rectangle, and we're looking at the diagonal of that rectangle. All right. Essentially, we're looking at a right triangle. And we know that this is 8 inches, and we know that this is 6 inches. Now, if in the back of my mind I remember this little baby triangle, that is 3. Oops, that won't work this time. Sorry. The hypotenuse is what we're looking for. Would it work? Yes, it would. What am I saying? Let me try to get that baby back in here. 3, 4, 5. Well, 3 times 2 is 6, and 4 times 8, or 4 times 2 is 8. So 5 times 2 is 10 inches. If you recognize that it's the mama to this baby, you can shortcut. If you don't, here's what you would do. You would take your 6 and 8. So we have a squared plus b squared equals c squared. And we know a and b. We know 6 squared and 8 squared. We're looking for c squared. 6 sixes are 36. 8 eighths are 64. And then I add together. That'll give me c squared. That is 100 is c squared. And the square root of 100 is 10. So once you get the 10 inches, you still have to apply the cost. And this is going to be a proportion if you want to do it this way. I know that 1 inch costs $3.50. And we have 10 inches on the diagonal. So you will multiply the peanut, 10 times 350, which is going to be 35, divided by 1 is $35. So it will cost in labor $35 to do this picture. She will also have to pay the materials. This is similar to how you would calculate the size of a television. If you buy a 55-inch television, that 55 is on the diagonal. That's a very good application for this theorem. All right, this is another good one. Ramps. A 13-foot ramp is attached to a 5-foot high loading dock. What is the distance d of the bottom of the ramp? I always like to sketch my own little picture so that I know exactly that I understand the problem. We know that this is 5 feet, this is 13 feet. You would definitely want to make sure that those units match. And they do. And we are looking for D. We're looking for one of the legs of this right triangle. So we know that we're looking for a leg. A squared plus B squared is C squared. One of the legs is missing. The other leg is 5. And the hypotenuse is 13. 5 fives are 25. 13 times 13 is 169. And so we're getting there. I have to subtract the 25 from this side. And I would do the same for this side. So this one's gone. That leaves me that leg squared and a 144. Take the square root of 144, that is 12. So that missing leg is 12 feet. And they did not allow me to use the calculator on that one. That's interesting. Number 5, I can use the calculator. Be very careful here. Mrs. Jones built a deck behind her house. What is the length of the unlabeled side of the deck? So we are looking for this unlabeled side of the deck, which is right here. Okay, they're trying to mess with me just a little bit, and they almost did. You cannot do Pythagorean theorem on this. There's two ways to know that. First of all, the right angle would have this hypotenuse. So there's that sliver of deck that we would not be counting. But here's the biggest clue. This is what jumped out at me immediately. And I knew, just my spidey senses said, I need to be careful here. Hopefully I told you to be careful. Here's how I knew. I have too many numbers. I have this one. I have this one. I have this one. And then I have a question mark. So that's usually a pretty good clue that I need to slow down. I need to be careful. But what if we did this? Let me erase that. What if I said, you know, if I did from here to here, not that, that was crooked. If I drew a straight line right there, I still have a right angle. And now I have a true right triangle. I have this side, which matches the question mark. I have this hypotenuse, which fortunately they told me is 25 feet. And I can figure this out in just a second. So here's the triangle that I'm actually trying to work with. It's the 4 that's sort of the odd thing out. And I need that 4 for this. This is 4 feet because it's parallel to that other 4 feet. So 28 minus that 4 feet is 26 feet. So I am replacing that 28 with 26 because I'm looking just at this blue triangle. And so the problem that I'm trying to solve looks something like this. And again, I like to make my own little sketch to just kind of cut through the mess. I know this is 26 feet because I took off that 4 feet. I don't want to use that. That's in that wonky part of the deck. So 26 feet, 25 feet, and we are looking for this number. That's a leg, because here's the right angle. So I'm looking for one of the legs. I know one of the legs, and I know the hypotenuse. And this cannot be right. What did I do? Here's what I've messed up, because hypotenuse has to be the longest side. And here's my problem. I can't do math in my head. 28 minus 4 is not 26. And I bet you already knew that. This is 24. I'm actually glad this happened because it lets me, first of all, show you that I do make mistakes. It also lets me show you that I know hypotenuse is the longest side. So I knew immediately something's wrong here. And usually, 99% of the time, the something's wrong is me. That is 24 feet. So I don't know one of the legs, but I know the 24 is one of the legs. And I know that hypotenuse is 25, and it is the longest side. Please say I can use it. I can use a calculator. I know some of these, but not all of them. So on my calculator, I'm going to do 24 times 24. That is 576. And then 25 times 25 is 625. Going to carry that other leg down. And then I'm going to subtract the 576 and the 576. This cancels. So I have a squared equals, I know it's small because I can look at the diagram and tell that it's small. 49. And the square root of 49 is 7. So I like 7 feet for my answer, and that is indeed one of the choices. That's a good question. It's a hard one though, because you cannot use this 4 feet in the hypotenuse. The hypotenuse is 25 feet. All right, it brings us to the end. Make sure that you have looked at those computation pages for Pythagorean theorem.